Hey guys, Mr. Betts here. I want to take a look at an example of a Maclaurin series that we want to write for a function that is made up of other functions that we know Maclaurin series for. So the first thing we're going to do is we know the Maclaurin series for e to the x and sine of x. And so I'm going to start by just rewriting this problem as the Maclaurin series for e to the x times the Maclaurin series for sine of x. Now, the next step is going to be a little bit tricky. It is an algebraic step, and what we're going to do is basically just distribute every term in one series by every term in the other series. Now, I want to point out that it's not possible to do that infinitely many times because they're both infinite series, but this question is only asking us for the first four non-zero terms. So what I'm going to do, I'm going to actually put a table in here, and this is something that I would kind of just do mentally. But I'm going to start by just looking for an x to the 0 term. Well, x to the 0 would be a constant times a constant, and we don't have a constant over here, so I can actually skip over that one and start with an x to the first term. So x to the first, we're going to get by doing x to the first times x to the first. Sorry, I'm having trouble with this parentheses here. So if we do an x to the, we could do 1 times x to the first. So an x to the 0 times x to the first is going to give us just x. Or we could also do x times x to the 0, which we don't have there. So then we're going to do an x squared term. So for x squared, we could do x to the 0 times x squared, which we can't do here because I'm going to color code this here. So we would have x to the 0 times an x squared, but there's no x squared term there. We could do x to the first times x to the first, so x times x is x squared. We could also do x squared times x to the 0, but we don't have an x to the 0 term there. So moving on, if we want an x cubed term, we can get x cubed by multiplying x to the 0 times x cubed. X times x squared, no x squared term there, x squared times x, and then we could also do x cubed times x to the 0, and there's no x to the 0 term there. So I've got 3 terms that are not 0, so I need one more. So for that one more, we're looking for an x to the 4th term. So for x to the 4th, we can do x to the 0 times x to the 4th, nothing there. X to the first times x cubed, x to the second times x to the second, nothing there. X cubed times x. Let's see, we're going to have over 3 factorial is 6. Uh-oh, that's going to be a 0 term. And then x to the 4th times x to the 0. Okay, so we don't have 4 non-zero terms yet because this x to the 4th term is going to drop out since they're opposites of each other. So we got to go one more. Need a color I haven't used yet. So the x to the 5th, hopefully I left myself enough room here. So we could have 1 times x to the 5th, x times x to the 4th, x squared times x cubed. That's going to give us minus x to the 5th over, so we got 3 factorial is 6 times 2 factorial, so 12. Then we could do x cubed times x squared, nothing there. X to the 4th times x. So x to the 4th times x is going to give us x to the 5th over, looks like 3 factorial. And that 5 factorial in there, 5 times 4 times 3 times 2 is 120. That's going to be a fun one to simplify. So simplifying here, we're going to get first term x, second term x squared. Next term, get a common denominator here. We're going to have plus 2x cubed over 6, so plus x cubed over 3. X to the 4th term drops out. x to the fifth term, it's going to take a little bit of work here. So we have 1x to the fifth over 120. Then we're going to have minus 10x to the fifth over 120, getting a common denominator. Next one, we're going to have to multiply by 20, so plus 20x to the fifth over 120. So 1 minus 10 is negative 9, plus 20 is 11, so plus 11x to the fifth over 120 is that fourth non-zero term. So again, what I did in the boxes, you don't actually have to draw out boxes, but I made a box for each degree, and then figured out what terms we would multiply together in the two Maclaurin series to get that degree term.